Philip Griffiths is the VP of Global Business Development and regularly speaks at events from DevOps to Internet of Things to cybersecurity. Prior to this, he worked for Atos IT Services in various roles, working with C-suite executives to realize their digital transformation. He lives in Cambridge with his wife and 2 daughters, and he is an all-round delightful chap.
So what we're going to be talking about is how we secure our data in an uncertain world, together with NetFoundry and Differentia Consulting. And this is a important topic. Well, I hope I don't have to introduce it, but I will introduce it. But we see cyber attacks on the increase. We've seen it for 4 years now. It's almost got to the point that unless there is a huge attack, it doesn't even make the news. In fact, right now there's like a hotel chain being massively under attack where they're having to process people coming in on paper, and it's barely made the mainstream press, even though it's affecting the real world. And that's because we just continue to have cyber attacks increasing. It's becoming an everyday part of life. And it's our opinion, NetFoundry and Differentia Consulting, that our data, our systems are important. And it's not just good enough to say, well, this is just normal, we'll just let it continue. Instead, we need to take a proactive approach to solving it. And if you start going to a large extent of the root cause, we see that the initial attack vector for attacks is scan and exploit of networks. If you take a step back, this all comes down to how we've built our digital systems. We've built them on top of the internet. The internet has been a wonderful invention that's allowed us to do huge amounts of things. It's allowed us to consume things like cloud. It's allowed us to consume things like SaaS. It allows me to go online and do my internet banking, or book a car or anything I want to do, all because of the internet. But the internet, by design, now everyone looks back and says, that was a bad design principle, but it was designed as a big, broad, open network where anyone could get from one point to another with absolutely zero checks or authentication or authorization put on top of it. And this is why cyber criminals are exploiting it, because it's so easy and quick to run automated exploits which cost almost nothing to check and try and see if they can attack organizations. And so we start asking the question, well, how do we protect our network? And various traditional solutions exist, whether it's implementing MFA or VPNs or bastions or dedicated private networks, firewalls, lots of rules, etc. All these things that we put in place to try and protect our applications and our data that sit on the network. We believe that's the wrong approach, whether it's setting up a VPN or setting up MFA or something like that. Effectively, we are still exposing things to the networks. We're still exposing them to exploit, but also we introduce a whole world of pain for the organizations, for operations, that has a total cost of ownership implication. But it also impacts our agility as an organization, how we can implement change for our users, how we can help them to, excuse the woolly term, but digitally transform and get more value from their data. Fundamentally, those are important aspects, and how we can do it in a way that allows us to exploit our applications and our resources is very important, so that we can get the most value for the business. And so our approach was to say, this is not good enough. You can't traditionally protect the network. So instead of trying to protect the network, instead we should focus on protecting our applications from the network. So instead of putting all of this complexity in place with VPNs and access control lists and MFA, and which still has 39% of UK businesses being breached or attacked. Instead, we're going to move to a new approach. We're going to give our applications their own overlay network, a private overlay network. And that private overlay network, as shown by these little arrows here, allow our users to connect into their applications, any application, in an incredibly easy and secure manner. And that enables them to ensure their applications and their data is secure by default. It cannot be subject to external network level attacks. I don't want to get too technical, but that's anything from DDoS to brute force attacks to credential stuffing, or anything that normally takes place on top of the internet, like IP scanning or anything like that. It just cannot take place because there is no inbound exposure to the internet. The only communication is on a private overlay. And this enables us to remove the weaknesses of our traditional security. It enables us to ensure our applications are not exposed to the internet as they would normally be with a traditional MFA solution, or that a malicious actor cannot do an MFA bypass attack, which is becoming easier and easier, cheaper and cheaper. In fact, I was listening to a podcast the other day where malicious criminal gangs are now providing MFA circumvention as a service, as they provide lots of other things as a service for other criminals. So instead, it enables us to increase our security, remove the pain of traditional security solutions, but also importantly, give our users a better performance and a better experience while reducing the total cost of ownership for the organization so that we can secure our data and we can use that data to drive the business outcomes of increasing revenue and decreasing costs. This is completely different to how we've previously tried to implement security approaches. And it enables us to move from being constrained by infrastructure and trying to bolt on traditional network infrastructure, particularly with hardware, into having a solution which is effectively security as code. It is software only. It is driven by APIs, and it makes us secure by default because we're not exposing ourselves to the networks, which are so easy to exploit. It enables us to bring an application first, a user first approach to our secure connectivity. Without going too much in depth, from a security approach, it is putting on its head how we traditionally think about networking. Normally, we build a network, it stands around for 3, 4, 10 years, and it's completely open to anyone to be able to exploit it. Instead, we implement specific or application-specific overlay connections when they're required on demand. And instead of inbound attacks or connections being allowed from network and our applications determining should this be allowed or not, instead, there are no inbound connections at all. Everything is outbound only based upon strong embedded identity, which is a key underlying principle of zero trust networking. Normally any endpoint can try to initiate a connection. Instead, we don't allow any endpoint. Only explicitly trusted and explicitly authenticated and authorized endpoints are allowed to connect, and only after they've done their authentication using both strong identity, but also optional extra posture checks. Is the device secure? Is it running an antivirus? Do I want to add my own extra level of multi-factor authentication from choose your preferred code provider, whether I use Google Authenticator, so it has 6 little digit codes that I put into my endpoint, and only once I do that am I allowed to connect to my applications, otherwise they're unreachable. So we're not just bringing a single point of authentication, we have multiple points of authentication on the endpoint while having no inbound connections, while being able to implement least privilege access and other important concepts like microsegmentation of zero trust networking. Effectively, we're able to put these all in place really easily so that the initial network attack vectors cannot take place. But also, even if someone does somehow get access to an endpoint, they don't have access to everything. They only have the minimal amount of privilege, which is the best practice that should always be followed. From an architectural perspective, kind of turning that text into a little picture, it kind of enables this overview. This is me in my green suit, as we were talking about at the start. If you missed the joke, apologies. This is me at home. I'm sitting in my own private network, and I'm able to connect to an application which itself sits in a completely private network. I'm not exposed to the internet. That application is not exposed to the internet. I have no idea where that application is. I don't need to know where that application is. My device has an endpoint, uses that identity, does all the magical things that just happen in the background. And as a user, I'm able to go to my application and it just works. A perfect example of this is that within our organization, we use a chat app, an asynchronous chat app called Mattermost. It's basically Slack, but open source. In fact, if I open it, you'll be looking at it, oh, that looks a lot like Slack, but it's blue rather than, well, Slack is like red or something. I forget what color it is. This sits in a private cloud environment. The only reason I'm able to access it is because I've got my ZT Desktop Edge deployed. Someone has said Philip gets access to Mattermost, and I've done my multi-factor authentication. If I turn this off, in fact, let's do that. I'll turn it off. I'll reload my app, and it won't load. It will keep spinning, and maybe at some point it'll say, you can't, oh, there we go, forbidden. I'm literally not able to access it. That is me not being able to access this private application because I've turned off my client. If I turn it on, then it's going to say, hey, okay, we know Philip, but he hasn't done his MFA. So now I'm going to quickly put that in, and hey, now I get access to Mattermost again. Oops, that's the wrong one. So as quickly as I remove my access, I'm able to quickly add my access back in. This is making private zero trust networking easy while having zero trust of the underlying network. The Mattermost server, or absolutely any application in the world, whether it's Click or I don't know, JD Edwards, or any application which you're using, they cannot be subject to traditional network level 3 and 4 type attacks. It's just not possible because they're not attached to the network. The ways in which we can deploy our technology is vast, but I'll only touch on it at a high level because this is more the how rather than the why. We can go on a network level. Great, I have zero trust of the internet because I have no inbound ports. We have images for all public and private clouds, can deploy it in absolutely minutes. Deploying a multi-cloud network is so easy because you don't need to worry about the traditional network. You just deploy a piece of software, put in a policy, and it all just magically connects. I don't want to deploy at a network level, I want to deploy at a host level, i.e. my Mac device or a Windows device or an iOS or Android mobile phone. Great, we've got all of those endpoints as well. For some of our customers, but maybe not you guys, I don't know. We also have a bunch of software development kits, which mean you can actually embed this into the application tier itself. Where this gets really interesting from a data perspective is, for example, we took one of our SDKs and we put it inside JDBC. JDBC is the driver to access Postgres, MySQL, or any other database. And it's mandatory. If you want to access that database, you have to use JDBC or some other type of driver. So we took that driver and we put our SDK inside of it. And now, by just changing one line of the string that a developer or web logic server kind of thing would do, it's able to participate as part of the private overlay network while being effectively clientless, because we don't have to deploy one of the host level clients or network level clients, because it can be inside JDBC itself, i.e., we can apply this technology to any use case we want. We even have one coming out really soon. It's in beta at the moment, called Browser. It's effectively a clientless access. I could give access to anyone in this call in a few minutes, and you wouldn't even know that you're part of an open of a NetFoundry network. It would be invisible to you. It's like making a private application accessible like it's a SaaS application. We call that capability Browser. We put a Z in it rather than an S. But effectively, it enables us to completely remove the friction, and that is our objective. How can we provide the most security, but do it in a way that for users is completely frictionless, gives them a wonderful experience, rather than the traditional, oh, I have to set up a VPN or I have to jump through these complicated steps. Instead, we can take away all that complexity and allow anyone to have secure connectivity in an incredibly easy and simple way. Now, there are many ways in which our technology can be applied. So I have a few use cases which show those capabilities. This one is a company called CERM. CERM provide a printing capability for their customers. It's like industrial printing. So it's like print on an egg or print on an industrial piece of equipment, or really complicated, not like a receipt at Tesco's or something like that. But effectively, to do their solution, they have a on-premise virtual server, a virtual machine, or some sort of compute that their customers load, and it connects to their backend application on the cloud. And so it provides system level communication between the customer premises and their backend cloud, while their remote users also access potentially the customer system and the backend. The key aspects for them, they actually spent around 3 years looking for what they termed at the time an SD-WAN solution which fit for their use case, enabled them to remove the complexity of VPNs. And we were the solution that they found that solved it for them. By using our technology, not only did they remove the pain of VPNs and traditional networking, but that enabled them to also reduce their support costs by 50%, or more specifically, grow their customer base without increasing their support costs, because they were able to automate how everything was set up and how everything was managed and configured. Now, instead of shipping a box to their customers and their customers having to set up firewalls and VPNs and VLANs and all this traditional complicated network stuff, instead they just say, here's an image, load it in your environment, and it does it. Everything else happens automatically because of the automation they've built. But interestingly as well, as you can see, they are using cloud infrastructure all across the world, quite literally 3 continents, and their customers are also distributed all across the world. And they saw massive performance improvement by using our product, because we're not just providing a secure overlay for any use case, we're also optimizing how traffic is routed on the internet. We are reducing latency, we are increasing performance and reliability, and for them, they saw tens to hundreds of milliseconds reduction, particularly like they had a customer on some really far-flung part of the world, and they had a huge performance increase by utilizing our solution. We have another organization, they're called 2K. 2K use us for system level access. So they connect retail stores to backend cloud solutions. For them, the key aspect was that they're able to load our software and our solution into the box that they ship to customer sites. So instead of having to send an engineer to site for every single site that they wanted to, instead they just ship a box and the box sets itself up. No VPN, no IPs, no VLANs or anything. Instead, they're able to grow as a business much quicker without having the operational overheads. And as a bonus, they get better performance and better security. But for them, it was really the automation aspect of being able to do things at scale without the traditional overhead. We then have customers like Ramco. Ramco are a ERP producer, obviously not on the scale of SAP, but they have thousands of customers, particularly in aerospace and helicopters and some military use cases and various different things. And for them, they were going on a migration to the cloud. They were moving certain applications from on-premise into AWS and Azure. And their first use case was actually, hey, we need a network to migrate the traffic. So they used us to create a connection in a few hours, and they were able to immediately start migrating the data rather than waiting weeks or months for traditional networking to be set up. And then they said, you know what? We would also like to move from using our traditional VPNs, our traditional MFA solutions, and instead have a zero trust overlay network. And they chose us against some other vendors in a RFP process. And now they have thousands of remote users, a mixture of salespeople, developers, engineers, etc., who are accessing their applications, which are now in 3 different cloud environments. Sometimes their users do that over VDI, sometimes it's via IP, sometimes it's just a direct connection. For them, some of the key aspects was the automation that we could provide them so that their users were managed in an automatic way. So again, they're able to not only have better security, but to reduce the operational overhead for their support organization. And so they could drive more agility and more change within their organization and have less complexity and cost for their business. For them, it's really about being a cloud first organization and being able to innovate quicker than their peers. And we've been a core technology as part of that process for them. We have another organization that does a similar mixture of remote users and backend access for their use cases. FW Insurance are one of the fastest growing insurance companies in Asia. And they used us, again, similar journey, actually very similar journey. Their first use case was a migration into AWS, and they went, oh, that's great. We don't have to go out and buy a direct connect and an MPLS link from our telco, which is horrendously expensive. Instead, we're able to have this great overlay solution on top of the internet, which gives us stronger security and better performance at a lower cost. But then they also started going, well, where else can we use this? Work from home and COVID-19. So they started rolling out to their remote users to be able to access the applications from home. They had some call centers who needed to get access to some solutions. They needed to connect some SharePoint applications into various different things. They had a third party, Blazecan, who was providing a data lake solution, and they needed to give Blazecan access to their resources. So they started using our platform for all of these different use cases, whether it was remote access, backend access, even system access into their various different applications across different environments. It really, for them, was the key aspect of not just providing better security and better agility for the business with a lower total cost of ownership, but the flexibility of how they could use that across different use cases as their business required through their different projects within their broad digital transformation journey, as they called it themselves. We even have some customers who apply us into industrial environments or autonomous driving environments, where they use us to connect from vehicles and IoT endpoints into applications which are hosted on the cloud. Whether that's public or private, it tends to be a mixture. And again, there is a mixture of why they do it, from we want the strongest security over any connection to anywhere, while having the agility and flexibility to be able to deploy their applications and their resources into any location, whether they want to do it today into Azure or tomorrow into AWS, or they're working with a new partner as something in Oracle Cloud or some a private data center. And now they don't have any problems or issues with it. For this specific customer in this use case, who was doing autonomous driving, the final one was total cost of ownership, or more specifically, within a vehicle, there are gigabytes or potentially terabytes of data being generated per day. And if that data is stuck on the vehicle, then they can't get the value from it. They can't see that instead of a vehicle going in for a workshop to be fixed, which could cost tens of thousands of dollars, instead they can just push a software over there update to fix it remotely. The problem for them is that a SIM card, when you start moving gigabytes or terabytes of data, is way too expensive. So what they wanted to do was to be able to use Wi-Fi when the vehicle was in a location that Wi-Fi is available, and therefore move a large amount of data at once, which we enabled them to do very simply, so that they could lower their total cost of ownership. And it always comes to these 3 points. We all know the 3 business benefits is: how do I increase revenue? How do I decrease cost? How do I reduce risk? Well, we're able to increase revenue because we can drive more agility and more innovation. We're able to reduce cost due to lower operational overhead and not having to worry about the traditional networking things of managing VPNs and firewalls and MPLS and all those things, while we reduce the risk of security attacks massively because they can't come from the network anymore. That gives, I think, a good overview of NetFoundry and how we provide the ability to secure your data in an uncertain world. There is much more details we could give in terms of other use cases or how this is actually done. I would love to open up for any questions, which then could be driving some of those extra areas that we can go into to explore on how or what, particularly specific to use cases that you may have.
So feel free to write them in the chat. Otherwise, I'm going to allow you to use microphones. Oh, exciting. If there's anything you want to. So feel free to jump on. In the meantime, just a quick filler question for Philip, who did a great job, by the way. Thanks, Philip. I'd like to ask, when you say it can be used in vehicles, that does include ambulances, does it not?
Yeah, 100%. The only question I would have to that is what is in the ambulance. Most likely there's something like a Raspberry Pi or a Dell, even some sort of edge box, some sort of edge gateway, which is running a small amount of compute, and that allows us to effectively deploy most likely one of our agents. So it could be a Docker container. It could be running Android. Some of our customers, they are using routers. So, for example, one of our customers has a IoT deployment where they deploy onto a Teltonica RUT240, which it's quite literally this big. It's fit in the palm of your hand, little industrial router that you plug a SIM card into, or you plug your LAN port into, and this runs OpenWRT, which is a stripped down Linux operating system, and they run our tunnel on it. This one specifically. So there are many ways in which we can deploy into the ambulance. In fact, I was discussing with another customer Tuesday about deploying into ambulances in a country in Asia. It's a use case that we see often. So the only question is, what device do you have there, so we can spec out the correct endpoint for it to work.
Brilliant. Fantastic. Thank you, Philip. So I'm going to be quiet for a second in case anyone wants to ask a question. Stuart's got one. Stuart, go for it.
Yeah. Hi, Philip. Thanks for that. Very interesting. I think I might actually know the answer to this, but I just wanted to check for clarification. We're seeing a bit of a movement now over the last few years around robotic process automation and software such as Power Automate and Power Apps, kind of putting the tools in the hands of almost business users, whereas previously they'd just be developers. And coupled with that, I read quite a frightening article on Wired earlier on this week around how hackers can easily use Microsoft's Power Automate to spread their deployments. Obviously, they would need to access the machine first and get into a particular machine. And I just wanted to clarify in that particular scenario how the zero trust solution would actually stop that from spreading, because apparently these hackers, once they're into that machine, whether it be through phishing or something else, it's relatively simple to do if the user's using something like Power Automate or something like that. Just interested to hear your thoughts.
Yeah, so there's two aspects which come to mind for that, and I think what is useful to understand is the various different ways in which things. No, let me rephrase that. There is, within cybersecurity, there's a concept of the I think it's called the cyber kill chain. It's been borrowed from military backgrounds, but it's effectively, how does a attacker go through the process of compromising a server or an application? Then it just rock up and compromise it. As you say, they have to initially make a breachhead and get into somewhere, and then they have to move across and laterally spread. And the way in which we reduce that is that, first of all, we make it impossible for someone to initiate an external attack, and that's done by we being able to have our applications in a way which is completely inaccessible to the external world. Now, someone may then say, well, there's certain services which you can't make private, or what if I'm using a Lambda function, or kind of go into this like cloud native world? What if I'm building an application, or what if I'm deploying into a place that you can't traditionally put private networking, and therefore you can't normally seal it off? And that's where we, in fact, we ourselves, we use our technology all the time. But one of the things we did recently was we showed the capability to connect a Lambda function, which is a PaaS solution for serverless computing on AWS, into our that Mattermost server I was showing. It's unaddressable on the internet, but yet we make a Lambda function which is sitting on AWS accessible to it by using our own technology. So first of all, there's the aspect of, if I can just make the service completely unaddressable, a hacker can't get to it in the first place. But then the second incredibly important aspect of zero trust is the combination of application microsegmentation and least privilege. And this kind of, if I go back to this overview, it's how do we stop people from laterally moving and exploiting resources? So let's give a good example for myself. On my endpoint, I get access to Mattermost on port 80 and 443. So going back to this overview, I'm able to talk to the Mattermost server at the application level, but nothing else. So if someone somehow did compromise my device, all they can do is go into Mattermost and send a message to my colleagues saying they smell. They can't actually SSH into the underlying virtual machine and start messing around, or they can't go to the, I think Mattermost runs on MySQL or some database or something, because I don't have access to it. It's literally impossible. You can't laterally move because there's no access to that service. In an environment where things are exposed to the internet and flat, e.g. a VPN, which has a public IP and then says, hey, now that I'm on the VPN, I get access to the whole data center. Oh, God, yeah. Using those automated tools, people could do some damage. But when we implement zero trust networking and we make it so that you can't initially attach because there's no inbound ports, and then access is on least privilege, microsegmentation, attribute based rather than role based, then we massively lock down the ability for people to laterally spread and cause more damage in the environment. There is then a whole bunch of other things to reduce it, but those are the main two aspects that really reduce that risk.
Yeah, thank you, Philip. That's really interesting. Thank you.
You're welcome, Stuart.
Thank you very much, Stuart. Any more questions? Feel free if you've got one. It gives us time to have a drink. It's nice, isn't it?
Yes.
Okay, just one more from me then, and that is, Philip, you're very switched on with all this, and you've got great awareness for where things are going. I just wondered whether you could give us maybe a little bit of a futurist opinion on what's going to be coming up in the next year and how NetFoundry can help with that.
So from our perspective, it's all about making zero trust, private networking, high security just as easy as possible. The demonstration I was giving with my endpoint, it's a better VPN. I still had to load this onto my device, and I had to, press this button and associate a JWT, which is way easier than using a VPN, and it all just happens in the background. But still, there's a little bit of operational work. So where we really focus our time at the moment is how we can reduce this further, how we can integrate into other tools and systems to give customers and users of our product better visibility, better automation, more joined up, but also how do we reduce the implementation burden even further. And that really comes down to using our more cutting edge capability of being able to actually put this inside the application itself, or as I was alluding to, the capability, again, you asked the question, so I'm going to give the answer, but really being able to make it so that you can have an application which has all the benefits of a private application, unaddressable, way more secure, etc., but have all the benefits of it being a public, or to seem like it's a publicly addressable application. Again, I'm pretty sure I said this already, but this is beta at the moment. It's not prime time yet. We're using it internally. It's all working internally, and we're going through the process of some beta deployments with customers. But effectively, this is going, we see this as being huge. No other vendor in the world can do this. I mean, very few vendors can even do our security approach, if any. But actually being able to take away the burden completely so that a user just accesses an application like it's on the public internet. They have absolutely no idea that it's in a private network, but that the application is. For us, that's game changing, because it removes the tug of war that normally takes place. Normally there's a tug of war between the part of the organization, the security team, like, hey, I need more security. And then the rest of the organization go, oh, you're slowing me down. And the user's like, oh, I hate your security. It's so frustrating. We are working really hard to completely stop that battle, because we can give everyone their cake to eat. Make it easy, make it secure, and make it zero hassle so that everyone just does it by default.
Subscribe for more Smarter BI content, or contact us at info@differentia.consulting so we can tailor Smarter BI solutions to your specific requirements. Thanks for watching, and stay smart.